morning, everybody.
Good morning.
How are you all?
Fine.
Fine. Okay. Let me take the attendance. Afla, Ajmina, Amaya,
Present, Miss.
Adulya,
Present, Miss.
Dusha. Dusha is not there. Jyotish, Karthik, Kavya,
Present, Miss.
Nachiket, Neeraj, Neeraj is there? No. Rangit?
Present, Miss.
Okay. Vaishnav,
Present, Miss.
Anjali, and Shruti. Shruti is there? Afla, Ajmina, Rishya, Jyotish, Karthik, Neeraj, Vaishna, and Anjali. Okay. See, you have to pay your tuition fees. So the attendance, some restrictions is there. So at the earliest, you have to clear off your tuition fees. Okay. Okay. We will start today's topic. Hope the slides are clear to you. Now, in the last class, we were dealing with local area networks. We were dealing with local area networks. Now, what is a local area network? Shruti? What is a local area network? Shruti has left the meeting. Okay, Afla, can you tell what is a local area network? Afla?
Share data in very small area.
Okay, it is a computer network that is designed for a limited geographic area. Okay, and you have seen what are the basic architectures of this local area network. You have gone with, I have just told what are the basic architectures. One is called it as the Ethernet. Second one is the token bus. Third one is the token ring. And fourth one is fiber distributed data interface or FDDI. And also I have told they all belong to the IEEE standard except the FDDI and they are under the project 802. Okay. And also you have seen this Ethernet, it has been classified it into two categories. One is the baseband category implementation and the other one is the broadband implementation. Okay, and also under baseband implementation, you can have four types. One is 10 base 5, 10 base 2, 10 base T, and 10 base FL. So in the last class, I have just told what is the meaning of all these things and I have stopped it there. Okay, so 10 base 5 means the meaning is it is the data rate is 10 Mbps, then it will make use of a baseband technology and the length of the cable, it is not extending more than 200 meter or 185 meter. And that is called it as the thin net. Okay. Now 10 base 5, it is 10 Mbps data and the supports a maximum length of 500 meter. Now 10 base T, it is 10 Mbps twisted pair cable you are making use of and the device must be connected to a hub or a switch. Now FL is the fiber technology. Now today you will be learning what is all this and what are the physical components present in each architecture. Okay. Now the first one we will deal with 10 base 5. 10 base 5 is also called thick Ethernet. 10 base 5, that is one of the baseband implementation of 802.3. That is also called thick Ethernet. Now, what is the meaning of that? Here, you can just see a diagram. I hope you all can see the diagram. So, in the diagram, you can have many devices connected. Now, what type of topology is being used here? Can anybody answer? Ajmina is there? Ajmina? What is the topology used in this? Okay, she is not there. Drishya is there? Drishya? No. Jyotish? Jyotish is there? No, he is also not there. Then Karthik. Karthik is not there. Then Neeraj. Neeraj is there?
Yes,
Yes. Tell me, what type of topology is this one? You can see many devices that is being connected and
miss ഒന്നുകൂടി പറയോ?
what type of topology you are considering here. You can see a diagram, right?
Bus topology.
Yeah, it is a bus topology. Now, what is the noise that is hearing? Okay, so it is a bus topology. Now, here you can see many devices are connected on that cable. And what is the meaning of this is, here the total length of a segment, see here the total local area network, it is divided into different segments. Okay, now each segment length will be of 500 meter. You can see in the diagram, the segment 1, the total length is 500 meter. Okay, now so at a time, I mean, in order to avoid collision, the maximum segments you can connect is 5 segments. So otherwise the collision may happen. So it is limited to 5 segments, where it is 5 segments means at most 2,500 meters and 1,000 stations can be connected in this. Now the difference, that is the distance between 2 stations will be 2.5 meter. Okay, so I was telling about 10 base 5 or the thick Ethernet technology. In that, how the segments are connected is they make use of a bus topology LAN. Now, the length of the segment, each segment will be 500 meter. It cannot exceed more than that. Now, the distance between the two devices will be 2.5 meter. Okay, now, this is now what are the physical components that are present in 10 base 5. You can see another diagram. See, at the backbone, you are making use of a thick coaxial cable. Okay, so the length of that cable will be 500 meter. The maximum length of the cable will be 500 meter. Now, what are the physical components present in it? I have just told you are making use of a coaxial cable. The second one is you are making use of a network interface card. As you can see in the diagram, that will be placed inside the station. Now, the third one is called it as the transceiver or the medium attachment unit. Now, fourth one is the AUI cables, or it is also called it as attachment unit interface cables, or another name you can call it as transceiver cable. So this is the topology of 10 base 5. Here, the physical components, what you are making use of, here it is a coaxial cable. Now, what type of coaxial cable? Already you have studied in the beginning of second module, the types of media, guided media. There you have studied coaxial cable, and I have just told you have got various categories of coaxial cable also. Now, in this 10 base 5 topology, you are making use of RG8 coaxial cable. Okay, and that is acting as the backbone of 802.3 standard. Okay, now the second physical component is the transceiver. Transceiver is also called as the medium attachment unit. Now you can see many stations that are connected to the cable. Now each station is occupied with the network interface card, and that is attached towards the cable with an, you can see each station that is attached by an AUI cable, and that is connected to an intermediary device called the transceiver. I hope that is visible for you in the diagram. You have a network interface card, you have stations, and stations are connected to the transceiver through an attachment unit interface or the transceiver cable. Now, what is the function of the transceiver? Now, transceiver, it performs the CSMA CD access method. Last class, you have just studied about the two access methods. One is the CSMA CD and the other one is CSMA CA. CSMA CD and CSMA CA. Okay, now what is CSMA CD? Who will be telling? Vaishna is there. What is CSMA CD? Vaishna is there? No. Ajmina, you have joined? Ajmina is there? Ajmina. Ajmina is there? No, she has left. Okay. So what is CSMA CD? Kavya, what is the expansion of CSMA CD?
Carrier sends multiple access with collision detection.
Yeah, so the type of access method that is used in Ethernet 802.3 is the CSMA CD process. Okay, so the transceiver will does that function. Okay, it will check for voltages and it will see whether any collision has happened. Okay, now this transceiver also acts as a connector. So how it is acting as a connector means it serves as a connector. It means it will attach the station to the thin coaxial cable. Okay, so two functions the transceiver is doing. One, it is acting as the it is doing the access method, and the other one, it is acting as the connector. Okay, so that is the second physical component of 10^5 topology. First one, I have told about the thick coaxial cable. The length of the cable is maximum, it is 500 meter, and RG8 coaxial cable is used. Now, the second physical component is the transceiver. That means each station is attached to an intermediary device called the transceiver. It performs two functions. One is the CSMA CD function, and the other one, it acts as a connector also. Okay. Now, the third physical component is called it as the AUI. AUI is nothing but attachment unit interface. So attachment unit interface means, the meaning is each station is linked to the transceiver through this cable. Okay, it is also called it as the transceiver cable. Now the maximum length of that AUI cable can be of 50 meters. Now, each end of this AUI cable, it is terminated with, you are making use of a 15-pin connector. I will show it in the next diagram. What is that AUI cable? So that is the pin connector. It is DB15-pin connector. Now, what is the function of that connector is? One pin, it is plugging into this NIC card, and the other one is to the port of the transceiver. Okay. Now, the length of the cable cannot exceed more than 50 meters. Okay, now you are having a tab also there, transceiver tab. So it consists of a connecting mechanism called tab, because if you want to pierce inside the cable, you require that tab. Okay, so these are the physical components present in a 10^5 architecture. One is the thick coaxial cable, the other one is the network interface card, the third one is the transceiver, and the fourth one is the attachment unit interface. Now you can just see a diagram how the connection of a station to the medium using 10^5. So that is clearly seen. You have your PC, network interface card is placed inside that, and that is connected towards the transceiver, and that connector, the cable is called it as a transceiver cable, and the transceiver is attached towards the thick coaxial cable with through a tap, and the maximum length of the coaxial cable will be 500 meters. Understood? Okay. Now you can also see one more diagram that is the transceiver connection. I have told you have an AUI cable that connects the transceiver and the network interface card, and that the connector is nothing but it is a DB50 connector. Okay, so this is about the first type of baseband implementation, that is 10 base 5. It is also called it as thicknet. Understood? What is the layout of this 10 base 5? Yes or no? Understood? And how it is laid out? Shruti? Shruti is there? Understood. What is 10 base 5? See, without logging in and going somewhere and not attending the class is not a good habit. So those who are there, you have to respond. Okay. Right. So now the next type of baseband implementation is called as the 10 base 2, or also called it as thinnet. 10 base 2, or also called it as thinnet. Now 10 base 2. Now what is the meaning of that? 10 Mbps baseband technology. The length of the cable is 185 meters. So approximately it is all around 200. Topology is this again. 10 base 2. What type of topology you are considering here? Ajmina is there. Ajmina. Drishya. Drishya is there. Bus topology. Yeah. This is also a bus topology LAN. Okay. Now, what is the advantage of this 10 base 2 when you are comparing with 10 base 5 implemented? Okay. But the main disadvantage of this 10 base 2 is it is only for a shorter range. That is, and that cable is called as RG58 cable. That RG58 cable you can easily install and move it. So I have just told it is now you have a network interface card that is inside the station, and that will provide an address. So the function of the transceiver in 10 base 5 is doing by the network interface card in this 10 base 2. That means it is checking for the voltages on the link. Okay. Now the connector, the type of connector that is used in 10 base 2 is the BNC T connector. Already you have seen the type of connectors in coaxial cable. There I have told what is this BNC and what is its specifications and all. Okay, so here you are making use of BNC T connector, which is having 3 ports. So one is towards the NIC, and one for the input and one for the output end. Okay, so this is just the topology of 10 base 2. So, and this is how it has been laid out. You can just see 10 connection of stations to the medium using 10 base 2. See, you have a NIC with transceiver. See, both it is connected. I mean, okay. Now here you have a BNCT connected, and that cable length should be 50 meters. Okay. This is the second type of baseband implementation for in 802.3. Now the third type is called it as 10 base T, or 10 base twisted pair cable connection. Now, what you can see in the diagram, what is the topology that is used here? Can anybody answer what type of topology is used here?
Star topology.
Star topology, yes. Now, what is the specification of star topology? You will be having a central hub. Okay, so that from the central hub, the devices will be connected to the central hub only. Okay, so 10 base T means 10 Mbps baseband and twisted pair cable you are making use of. And this is a star topology LAN. Now that cable is called it as the UTP cable, 4-pair UTP, unshielded twisted pair cable you are making use of. Now the maximum data rate is 10 Mbps and the length of that cable, it is of about 100 meter. Okay. Now you don't have individual transceivers here. So the networking operation is performed in the hub. The hub is doing all these things and the stations will be linked to the hub through an RJ45 jack. You can see in the diagram how it is being connected. So 10 base T, it is 10 base twisted pair Ethernet. And here you have a star topology LAN making use of a UTP cable, and the card is acting as the transceiver, and all the, the networking operation, it is performed in the hub, and each station is connected towards the hub with an RJ45 jack. Okay. Now you can see this is how this connection is going out in 10 base 5. The top part you can have clearly visible. So this is the central hub or the repeater hub. Through the UTP cable, it will be connected towards the PC. Okay, so this is how the connection is going on. Now the last type is called it as the 10 base FN or fiber link Ethernet. Fiber link Ethernet. Now you can see in the diagram. So it is also making use of a star topology. Now additionally, you have having an external transceiver here, and that is called it as the fiber optic MAU, medium attachment unit. So you're having an external transceiver here, and that is called it as the fiber optic MAU. Okay, now stations are connected towards the external transceiver through an AUI cable, that is 15-watt transceiver cable you are making use of, and this transceiver is connected towards the hub using a fiber optic cable, as you can see in the diagram. So stations, they are connected to the external transceiver through an AUI or a transceiver cable, and the external transceiver, they are connected towards the hub using a fiber optic cable. Okay, so this is the other fourth type of baseband implementation. Okay, so understood how 802.3, what are the physical components present in each baseband implementation. You have gone with 10 base 5, 10 base 2, 10 base T, and 10 base F. Okay, now the other type is called, I have already told Ethernet when I was teaching you CSMA CD, I have told this is used in traditional Ethernet. Okay, so the access method that is used in Ethernet is the CSMA CD, carrier sense multiple access collision detection. The working principle and all I have just explained in the last class. Okay, so just remember the access method that is used in Ethernet is the CSMA CD. Now you are going to deal with the addressing method. Now how Ethernet, the addressing is done in Ethernet network. Now usually each station on an Ethernet network has its own network interface card. So whatever stations are connected on that network, they are having an NIC card, network interface card. Now actually this network interface card, it is fixing inside the station. Okay, and you will be having a 6-byte physical address. In the slide, you can just see. So the address, the physical address will be of 6 bytes. 6 bytes means 48 bits you are making use of. So when you are converting into hexadecimal notation, it consists of 12 hex digits. Okay, so NIC, you will be having a network interface card, and it is inserted inside the station, and it is provided with a 6-byte physical address. Okay, now the number on each network interface card is unique. Okay, now this 48 48 bits, you can written it in hexadecimal notation with a colon separating the bytes. So here you can see I have just taken an example 06, 01, 02, 01, 2C and 4B. So how you have to separate this? By making use of colon, you have to separate it. Okay, now you can have three different types of addresses. One is called the unicast address, the other one is the multicast address, and the third one is the broadcast address. So addresses are of three types. One is unicast, the other one is multicast, and the third one is the broadcast address. Now unicast means the frames comes only from one station. Unicast means the frames come only in comes only from one station. Usually the source address is always unicast address because source is generating the address. So source address is always unicast address. But the destination address can be unicast, multicast, or broadcast addresses. Now, how you can differentiate these three? How you can differentiate a unicast address, a multicast address, and a broadcast address? So you can just look into the slide. I have just written byte 1, byte 2, etc. up to byte 6. Now, how you can differentiate is you have to find out what is the LSB bit of the first byte. You have to identify what is the LSB bit. LSB bit means least significant bit of byte 1. If it is 0, it represents a unicast address, and if it is 1, it denotes a multicast address. So if it is 0, it represents a unicast address, and if it is 1, it represents a multicast address. Now, there is a special case of multicast address in which all the bits are ones, and that is called it as the broadcast address. Understanding? Addresses are of unicast, multicast, and broadcast. Unicast means you have to find out, check whether what is the LSB bit of the first byte. If it is 0, it is a unicast address. If it is 1, it is multicast. And if all the bits are ones, you can call it as a broadcast address. Okay. Now, there is a question for you. You have to identify the following destination address. Three questions are given for you, A, B, C, and you have to identify what type of destination address. I have told destination address can be unicast, multicast, and broadcast. So three questions are there, and you have to identify what type of address is this one. So Ajmina is there. Ajmina is there. Yeah. Tell me. Okay. Tell me what is the first address. You just go through example A or the question A and find out which type of address is that. I have told how you have to identify. You have to identify each byte. You have to consider byte 1 and you have to identify what is the LSB bit of the first byte. It is multicast address. If all these 6 bytes are ones, then it is a broadcast address. So if it is like that, your question is, the first one is 4A is to 30 is to 10 is to 21 is to 10 is to 1. Now how will you identify which is the first byte here? Byte 1. Byte 1 means you are representing in hexadecimal notation. So the first bit is 4, and then the first you have totally byte 1 means 8 bits. So the 8 bits you are representing it as the first is 4 and the next is A. So here A is the LSB bit. Okay, A. What is the binary representation of A? What is the binary representation of A?
1010.
Ajmina. 1010. Now what is the LSB bit there? What is the LSB bit there? You have told A is denoted as 1010. Now what is the LSB bit? Least significant bit. Is it 0 or 1?
0.
0. If it is 0, I have told it is a unicast address. Okay, so the first question, it is a unicast type of address. Now what about the second one? 47 is to 20 is to 1B is to 2E is to 08 is to EE. Again, in order to identify the destination address, you have to check the first byte. First byte means 47 you have to identify. Now, what is the corresponding binary representation of that 47? In hex only it is given. Okay, so 7 is the LSB bit here. So 7, what is the binary representation? What is the binary representation of 7?
0, 1.
Drishya is there? 0, 1, 1, 1. Okay, now what is the LSB bit there? Yeah. What is the LSB bit? 1. So 1 means what type of address is that one? It is a multicast address. Okay, so the LSB bit you have to check. Yeah, it is a multicast address. Okay, now the third type of address. What is that? Check it and tell me. The third type of address. Karthik is there? No, he is not there. Vaishna. Yeah, Vaishna, you can answer. What type of address is that one?
Broadcast address.
It is a broadcast address. Why it is a broadcast address? Because all the bits are 1. So all the bits are 1, so it is a broadcast. This is how you have to identify what type of address is this one, unicast, multicast, or broadcast address. Okay, so this is about the what we have learned is you have seen what are the different types of addressing schemes and how different addresses in 802.3 and what is the access method used in 802.3. Now the last topic in this 802.3 is the frame format. Now frame format, IEEE 802.3 specifies one type of frame which consists of 7 fields. Very, very important. Usually in the exam it will be asked, explain about 802.3 frame format or MAC frame. In short, you will be calling it. So when you are considering this diagram, you can just see it consists of 7 different fields. The first field is called as the preamble, which is of 7 bytes. Now you have got SFD, 1 byte, destination address, source address, 6 bytes, and length of the PDU, that is 2 bytes. You have the data, and finally the cyclic redundancy check. Now what is the meaning of each one? The first one is preamble. Preamble means it consists of 7 bytes. 7 bytes means 56 bits of alternative zeros and ones. Okay, and then that preamble bit is used to alert the receiver about the coming frame. The frame is going to send. So it is an alert to the receiver section. Okay, so you have 7 byte preamble section, which consists of alternative zeros and ones, and that alerts the receiver about the coming of the frame. Okay, now the second field is SFD. SFD means start frame delimiter. Start frame delimiter. It is a 1 byte address. Now, what its function is, it tells the receiver that whatever is following is data, starting with the address. So whatever is coming is the data starting with address. Okay. Now, the third field and the fourth field, they are the addresses, destination address as well as the source address. Now the destination address, it is 6 bytes. It consists of the physical destination address of the packets. Okay, now if the packet has to move from one LAN to another to reach the destination, now the destination address, what it contains is, it contains the physical address of the router that connects each LAN. You will have 2 different, see, you cannot always tell that the data is going to a single network. It can be to, the data has to cross many networks and then reach the destination. If that is the case, the address will be of that of the router. Okay. Now the next one is the source address. Source address, it is of 6 bytes again, and it contains the physical address of the center of the packet. Okay, whoever is sending and their address will be will be placed in the source address. Now the next is the length or the type of the data. It is usually of 2 bytes. Now how many bytes are present in the data field? That is represented by this one. Now the data in a MAC frame, you can call it as the protocol data unit or PDU. Okay, so the total length of the PDU is denoted in that fifth field, and data and padding is nothing but it is the actual data. It consists of 4 fields. One is DSAT, SAT, control, and information. Okay, now if the header consists, now what is that control information? Control field is used for flow and error control. Already you have seen what are the flow control methods and what are the error control methods. Okay, now the other 2 header fields, that is DSAT and SAT, they are nothing but destination service access point and source service access point. Okay, they are nothing but the protocol that uses the LLC layer. Now the last field is the CRC, cyclic redundancy check, that is the error detection frame. Okay, 4 bytes are used for error detection. So this is about the MAC frame. So very, very important. You can have 7 fields, a preamble, a start frame delimiter, you have destination address as well as the source address, you have the length of your protocol data unit, you have the actual data, and finally the cyclic redundancy check. Okay, so the explanation, it is there in the slides itself that you can just refer it once I send. Okay, so this is all about the local area network, and you have to study what are the baseband implementations in this 802.3, and also you have to study the frame structures or the frame format of 802.3. What are the physical components present in each baseband implementation, and what are the functions of this thing, and what type of topology each architecture is being made use of. Okay, understood today's topic. I start baseband implementations. I have told what is their topology and how the physical components are connected. Okay, and after that we have gone with the addressing schemes in 802.3, and also you have seen the frame format of 802.3. Right, now next hour one more topic is left in your second module, that is IEEE 802.11, which is nothing but the wireless LAN. And after that, today itself, I will be sending the unit test questions as well as the assignment questions of module 2. So assignment, you have to submit it. Today I will be releasing that. So read the instructions, what is given for you. And after that, answer it accordingly and take your time and write the assignments. Don't write it in a hurry, like one day you have to finish, nothing like that. 1 week time I'm giving for you. Today is 23rd, 30th, you have to submit your assignment. So why I'm giving that much date is you have to refer your textbook, your lecture notes, your notes, everything you have to refer, and then you have to answer all these questions. Okay, so I have told for the exam purpose, you have to write your assignment also. And 2nd, 3rd, and 4th, you will be having the unit test. 5 students per day. The register numbers I will be just mailing through Linbase. So Linbase, all the materials will be attached. Okay, today itself I'll be attaching it. So go through the Linbase. What are the questions that are asked in unit test? 6 questions I have asked. 2 questions like previously. 2 questions you have to answer, but it is of 20 marks this time. Okay, so you have to work hard because second module is very, very vast. It consists of 2 layers of the OSI as well as the internet model, that is the data link model layer as well as the physical layer. So write it clearly. I have told you what are the drawbacks in the first assignment. Few people have not called me yet. That is starting with Neeraj to Shruti, you have not called me. So I have given you time for calling, but you have not called. I don't know the reason for not calling. Anyway, today, the remaining students has to call. I have to point out your mistake, what you have made in your assignment, as well as your quizzes, what I have conducted so far. So with all that things, what all corrections I have told, you have to just write the second module assignment and submit. Okay. So thank you. We will meet in the next class.